In this video, I'd like to give you a little more explanation to worksheet number 1 for our Intermediate Algebra Math 140 course. This is the Module 1 worksheet on functions. You can find this worksheet on Blackboard, and be sure to consult Blackboard to ensure you know the due date and how to submit the assignment. When it comes time to submit the assignment, you'll need to scan your worksheet as a PDF, and then you'll need to upload your worksheet on Blackboard. If you prefer not to print this worksheet, that's okay also. Make sure that you have on your own line paper copied the chart and answered both of the questions on your line paper, and you can scan and submit that paper also. However, please ensure that you have saved your PDF as one single file. If you only have one page, that'll just happen naturally. But if you do use more than one page and you need to scan two separate pages, you'll need to combine the two pages into a single file. You can consult Blackboard to find a video I've created for you to walk you through how to scan and submit a PDF on Blackboard. And please don't hesitate to contact me if you do have any questions about that process. Well, here's our graph. What we have in the graph is a 200-meter race that ends in a three-way tie. The graph shows the distance as a function of time for each of the three winners. So we can see that although the three winners weren't together at every moment in time, by the time they hit the 30-minute mark, and by the time they hit the end of the 200-meter race, they were at the same point. Thus, we had a three-way tie. Now, one other thing I'd like to explain about this graph as you see it is I would have liked to have seen this graph, and I'll share with you that I didn't create this graph, though I think it's a wonderful graph to use. I would have liked to have seen the end points here at t equals 30, d of t equals 200, so this end point. And I would have liked to have seen the starting point at 0, 0. But our graph continues off. So if you could just disregard that the graph starts before 0 and ends after 30, really the graph should have a domain. That means what our axis down here, our horizontal axis, the domain should have gone starting and including 0 up to 30, ending at 30 and including 30. The range should have gone from starting at 0 meters, because the range is going to be our distance, and going up to 200 inclusive. Inclusive means that we're going to include the 200. So here's our graph. If you want to understand it a little better, but let's just trace one of the runners. Let's trace the blue runner, runner A. What we see about runner A is they started out at 0 meters when the time was 0 seconds. When we hit 5 seconds, we could see that the runner was just below the 50 at this mark. I want to call it 40. So in 5 seconds into the race, the runner A, the blue runner, had gone 40 meters. When we get to 15 seconds, we can see that runner A had gone 2 marks above 100, and each mark is representing 10 meters, so 110 meters, and so on. Do you see that you could write ordered pairs for this runner? We could say that for runner A, we have the ordered pair at 0 seconds, because seconds is our independent variable. When the time was 0 seconds, the runner had gone 0 meters, and this is an ordered pair. Don't confuse that with the format for these interval notation, domain and range. The interval notation, I'm using a bracket to show that we included the 0. For an ordered pair, it's always parentheses. When the runner had hit 5 seconds, we can see that the blue runner A had gone 40 meters. At 10 seconds, runner A had gone, it looks to me like it's just above the 80 mark, so I'm going to call it 82. And so on. At 15 seconds, I could write the ordered pair, I'm going to call it right at 120. And so on. I could find the ordered pair for each of these places. And then our 30 is a nice easy 200. At 30 seconds, runner A, the blue runner, had gone 200 meters. So that's how you could interpret this graph. And you could do the same for the green B runner and the orange C runner. So completing the table, what it's asking us to do is fill in those numbers. In 15 seconds, how far had the blue runner A gone? Let's call it 120. At 20 seconds, I'm going to call it 150 meters, and so on. And you could fill in those ordered pairs. So the seconds is the independent variable, and the distance is a function of the time, and that's our dependent variable. You might be most accustomed to seeing these variables as an x and a y. So x is the horizontal axis, y is the vertical axis. Here we're going to let y be represented with a function d of t, and our vertical axis is t for time. You should be able to finish this chart by calculating those remaining 6 ordered pairs. Once you've completed that chart, you could answer some questions about the runner. So how many meters did each runner complete after 15 seconds? So after 15 seconds, we'd have to look at 15 seconds, we were at the 120 mark. And if the total was 200 meters, then how far did runner A go after 15 seconds? I could subtract the 120 that runner A has already gone to get how far the runner went after 15 seconds. And I could do the same for each of these runners. 200 meters was the total. The green runner B had already gone 100 meters. So how far did runner B go after? And then finally, runner C, who started out the slowest, but still ended. Oh, I'm sorry, I wrote the wrong number there. I meant to write a total of 200, right? So we started at 200, or we ended at 200. And at 15 seconds, runner C had gone 80 meters. So I could subtract to see how far each runner ran after 15 seconds. And based on this information, who would you expect to win? So based on, let's say that this means based on where they are here at the 15-second mark. 15 seconds into the race, I would have put my bet on runner A. Runner A was quite a distance ahead of C and slightly ahead of B, so it sure did appear that our runner A was significantly ahead. And why did the race end in a tie? What happened? Well, let's go back to looking at the graph to see what happened. Let me do this instead, if you don't mind. I will just carry our graph over to where we are. Okay, now we're ready to go. So how many meters did they each go? And then based on this information, who would you expect to win? And then why did the race end in a tie? What happened? So at the 15-second mark, we had blue ahead, but then notice that if we look at this graph for C, his rate, like how fast they were running, has increased. We have a higher slope. The change in distance with relation to the change in time, or the slope, started to go higher. It started increasing. What was the green runner B doing? If you look at the green runner B, you'd see that they were nice and steady all the way along. And then runner A started out faster, then started to slow down slightly. So what happened? They each changed their rate. They were going a different speed throughout the race, other than B, who stayed steady all the way through. How did runner B run the race? As I mentioned, runner B was nice and steady. If we looked at the graph of just B, you could see that we get something that resembles a line. And a line can be represented in a graph with by a linear equation. A line is the graph of a linear equation, or in this case, a linear function. You may recall the formula, or the shouldn't really call it a formula, but the equation format: y equals mx plus b, slope, intercept form, where m is the slope, b is the y-intercept. We could write this function b as a line. The distance with respect to time, so that's d of t, equals mx plus b, where m is the slope. That's how much we're increasing compared to, or decreasing, plus b, where b is the y-intercept. If I wanted to write this equation, I would need to find an m, the slope, and a b, the y-intercept. Well, the y-intercept is easy for this one. It's just 0. The y-intercept is 0 because when I look at the y-axis, or the vertical axis, we see that we cross that, the green line crosses that axis at 0. The slope is a little more tricky. What I've got to look for is the rise over the run. How far did we go up or down? In this case, it's an increase. And that looks like it's a 100 compared to the run, or the change in y. A few things to remember about slope. We could use this simple triangle for change. It's the change in y over the change in x, the ratio of the rise over the run, or the change in y. So if we had two y's, we could subtract them to see what their difference is, and then subtract their respective x's to see how far the x's are apart, or their difference. In this case, it looks like from 0 to 15, the change was 15 units. We can reduce that 100 over 15 by dividing both the 100 and the 15 by 5, and you'd get 20 over 3. Once we know that the slope is 20 over 3, and we already had that the y-intercept b was 0, we could put these into the function, and we'd have the distance with respect to time is 20 over 3 times x plus 0. And then our final answer, we don't need the plus 0. We could drop that from our response and just have the distance with respect to time is 20/3 of x. Did you notice that that 20/3 is going to be a representation for how fast that runner was going? Because speed has to do, or velocity has to do with our change in distance, how far you've gone, with relationship to how much time has gone by. So our 20 is how much the distance changed, and the 3 is how much time has gone by. So 20/3. But the distance with respect to time equals 20/3 x. And this is an example of a linear function. And when we graph a linear function, we get a line. I hope you found this video helpful. If you do have any questions, I want to point you to a few resources. Please always feel welcome to email me. You can email me with any of your questions for the course. I'm here to help you, and I hope you never feel like you're left here on your own to figure everything out. So when you get to something you're not sure of, please send me an email or visit me during the virtual office hours. You could also visit with a free St. Louis Community College tutor. Now, don't be fooled by that name free. They're not volunteers. They're not working for free. They're working for pay, and they're highly professional, exceptional tutors, but they are free of charge to our college students. So make sure you make good use of that free service and get the help that you need.